Okay, today we will start with the first week lecture, which will be about an introduction in database concept and design. Just one thing before we start, in database, lectures are dependent. So when we take a lecture, make sure to understand all of it, because maybe in the coming lecture, you will need some information from the previous, and you don't want it to be stack one on the other without understanding what's going on in the previous lectures. So make sure to follow up to catch up what's going on, especially in the lectures, to just avoid to not having any problems in the future. So today we'll start an introduction to database concepts. This is the chapter outline. We'll have an introduction, then an example, which I'll go back and forth to that example to clarify some of the points, characteristics of the database approach, actors on the scene and workers behind the scene, and advantages of using database management system approach. Today, inshallah, we'll have an introduction to database concepts, the first chapter. The chapter outline, we will have an introduction, an example. This example, I'll go back and forth to it because I need to clarify a lot of points. So it's a good example to follow. A characteristic of database approach, actors on the scene and workers behind the scene, and lastly, the advantages of using database management system approach. Overview, here's some of the applications that are using database. So I'll just go through them quickly, and when we go and understand more about the database, you will know how they are working. So for example, we do have the traditional data applications where we just save texts and numerical informations. I believe you already have worked with Access, Microsoft Access before. So if you have done that before, you already have an imagination of that, how it's going to be a database looks like. It's just rows and columns, and you save text and numeric information. We have the multimedia database where you store images, audios, clips, and video. We have geographic information system. And this one, we just more concerned about analyzing the maps with the data, the degree and other stuff, satellites, images, all of those will be saved in the graphical information system. Data warehouse and online analytical processing systems. These are located in big companies and big corporation where we have a very big database that saved a lot of information. And based on these databases, we can reach to decisions. So I can get back, for example, the sales that we had last year, and then after that, I can have a decision for what we will do in the coming year, and etc. So that kind of data, it's in big places or big companies and organizations. We also have real-time and active database technology, control industrial and manufacturing processes. So before we start, we have to understand what's the difference between data, database, and also I might add information. Data, as you might already expect it, it's just an information, a record, it's a fact completely known by you and can or have an implicit meaning. So for example, if I just give you 05550789 and 10 digits in total, you will figure out that it's a phone number, and that's data. If I just give you, for example, Khalid, you will figure it out, it's a name, or it might be a last name. What else? If I give you 2011, 2021, you will figure that it's a date. And that's it's by itself, it's a data. Okay, so it's known facts that can be recorded, okay, and have implicit meaning. The database is a collection of related data. So when I'm having a database, for example, about university, which will be the example that we are going to cover, inshallah, in the coming slide, I'm talking about a university as a database. So all the information that will be saved in that database is related to the university. It's not chaotic. It's not sparse data that's coming from everywhere around the world. It's going to be information or data that's going to be related to the university. For example, faculty names or student information, or maybe technicals, or any other maintenance people that has working under or behind the scene. So all of those information, or all of this information are related to the people working under the university, or might be department or whatever. So database is collection of related data. In this case, we are talking about university, so it will be related to the university. And I told you I'll talk also about information. So whenever we have collection of data putting together, we can reach to an information. For example, if I'm having the budget as a database, I'm having the what I bought and sold last year. So based on this information, I can make decision, and that decision is an information for me. So did I spend a lot last year, or did my expenses were low? And how can I get that, or how can I conclude that? Based on the database that I have. So I can reach information. Okay. Information is just an extra thing. It's not included with you. I might add some information when I'm talking in the slide to just clarify things for you. Okay. What you have in the slide, it's just what it will be, or what you will be examined on. Make that also clear for you. Mini world or universe discourse. What does that mean? So mini world, a database, it covers a mini world, or a mini thing of the real world. For example, we have a database for University Imam Abdul Rahman bin Faisal. So it's a part of the real world, but it's not the whole real world. We have millions of universities around the world, right? So University Imam Abdul Rahman bin Faisal University is a part of that real world. So this is what mini world means. It's a part of database. So database, it's a mini world. It's an aspect of the real world. I told you about that before. Logical, coherent collection of data with inherent meaning. So all the information, all the data in the database must be coherent. They have a relationship between them, and also built for a specific purpose. We don't have a database that it's just there for no purpose. There is a purpose behind it. So a database for university, it will collect all the information regarding the university. A database for a company, that will be all information about the company and only that company. Okay. So again, there must be a purpose to build a database. So these are some characteristics of a database. Example of a database, large commercial, it's Amazon.com. A database management system, which what we would talk about mostly. We were just been talking about a database alone. Now we will talk about database management system, or the shortcut or abbreviation, it's DBMS. Okay, and we'll talk about this for the whole lecture. It's a collection of programs, so you can manipulate the data using, or the database using management system or database management system. So the database by itself, it's just a collection of records and information. If you want to add, if you want to update, if you want to store, if you want to change, if you want to do anything on the data, you have to use a management system or a collection of programs. And because of that, it's called database management system. So you are managing the database, enables user to create and maintain database. So you will maintain them for a long period of time. So you will have maintenance, you will have adding, you will deleting, creating, updating, whatever on the database using the database management system or DBMS. The first step that you will do in the database, it's defining a database. So we have defining, constructing, manipulating, and sharing. With defining, you specify the data types, okay, and the structure and the constraints of the data to be stored. What does that mean? So I'll give you an example. I'm having you, the students in one class. So I'm going to create a data or a table that's named, for example, room or CIS group number 5, let's say. What inside that, I want to have columns. For example, I would like to have 5 columns. The first one, it's first name, for each student that I have, the last name, the ID, maybe the date, and maybe how many courses do you have. What I'm just doing right now, it's defining a database. So I'm saying I'll have a database the first table that inside the database is called students, or for example, a course. And I'm specifying the data types. So I want the first name to be a string. The last name I want it to be also a string. And for example, the first name, I need it to be a 10 characters. The last name, for example, 20 characters maybe. The ID, it's 10 digits. What else? The date, I want it to be as a date format, not just a string. I want to be a date. How many courses, I want it to be a number from 3 to 5. And when I say 3 to 5, now I'm putting constraints. So if a student has less than 3 courses, the system will reject it. If a student has more than 5 courses, the system will reject it. So what I'm putting right now, I'm putting constraints. And this is constraints, structures, and data types. So also the structures, how many tables you want to have. I just have, for example, now one table, it's called course. I might have a different table called room. So that table maybe has, or maybe have the different room and the capacity of each room, who can access that room, and etc. So that defining, still I'm not adding you inside the table. I'm just defining this the way I want the data to be entered. And before talking about constructing, we will have something very important to understand, especially in this course. It's called metadata. See what I was talking about when I was creating the table that's called students or room. I specified the tables column, right? The table columns. So I have 5 columns. I want them to be integers. I want them to accept 10 digits for ID, 5 characters for first name, 10 characters for the last name. What I'm creating right now, it's defining, right? And this definition, it's called metadata. So, and that definition is stored in the database management system. How comes? So when I create the table, the database management system will have these characteristics. Okay, I know that you want first name to be characters, 10 characters, last name 15 characters, for example, ID 10 digits. The date you want it to be in date format, not just a string format, so that it's metadata. It's data that describes data. And that's quite important in database management system. So I can configure the way I want my table and how I want my table to be in shape based on the metadata. So for the future, if I want to change the metadata from, for example, like the first name, I figured out there's some names are there's some names that are longer than 10 characters. So I can change that easily through metadata to be, or to change the first name to be 15 characters, for example. And that can be changed in the metadata. I won't touch the data itself. Okay, so the metadata, just imagine it's a describe of the data, or describe of the columns that you have, how you configure them and how you build the tables. So that are the metadata, or these are the metadata. Database definition or descriptive information stored the database management system in the form of database catalog or dictionary. We will talk about that more in, we'll talk about this more in the coming slide, but the metadata is saved as database catalog or under a dictionary. Okay, so this is the place where it's saved. And it's a part of defining again. What about constructing, which is not written in the slide, but you can find it in the book. And again, in whatever is not in the slide, it's not mandatory to be remembered, especially in the midterm or exam. Whatever you have in the slide in front of you, it's that what you will be examined on. But just to give you how the data is built, I want to know, I want to let you know that there is one point before manipulating and after defining, it's constructing, where you will fill the information. Now I do have the table, so I'll start put your names on it. I'll start to put your first name, last name, ID, the date, and how many courses do you have. And that's it's constructing. And after that, now I have the tables defined already. And I do have the table constructed as well. Now I'll start with manipulating. In the future, let's say I want to update some of you so like some of you had or has changed some of the information that we might maybe add a new course or something. So your information is already saved in the database. So if I want to change, like update, I would do the manipulating on the database. And that's called manipulating. It's either be query or update. With the query, you are asking for information. For example, I want the information regarding Nasser, for example. So I would just put the ID of Nasser and all the information about Nasser, first name, last name, how many courses, and his, what else? The date of birth, for example, will be returned for me. That's query. So I'm asking and I'm getting back. Update, I'm going to, for example, put the Nasser ID and I'm asking the database management system to update how many courses it had. For example, he has 4 courses. Now I want them to be 5. So I just send whoever with this ID, change his course from 4 to 5. And also generate reports. All of that considered to be manipulating. So we finished with defining, constructing, manipulating. Now with sharing, one of the marvelous, let's say, feature in database, it's sharing. With sharing, you allow multiple users and programs to access the database simultaneously. Focus with simultaneously, okay? For example, you have all, I believe, an account at the university and Blackboard. So Blackboard is basically a database as well. It has all information about us, and you are considered to be, or you have already, which I will talk about it maybe later, a student privilege. You cannot add materials to Blackboard. It's vice versa on us. We can add some materials, but I cannot add the new courses for me in Blackboard, for example. That is the responsibility or that privilege already given for someone else. And all these privileges, it's shared between us. So everyone has its own privilege. But the thing that I wanted to mention here, we all like working simultaneously on the same database. You can retrieve, like getting or download anything from Blackboard, and I can as well uploading at the same time without conflicting. And this is one of the features that database provides for us. Application program, again, let's assume that we are using Instagram, okay? In Instagram, every one of us has the application in his phone. And whenever you like browsing the images or browsing the people you are following, Instagram keeps giving or keeps sending this information for you. And that basically it's application program. The application program that you have in your phone at Instagram, the application, it's going to the database, access the database and sending queries, like asking, give me the photos for that man or that company, and you will return with all the photos of his account. So that's what's going on in application program. It's just basically an application that's going and access database and retrieve information. And this, I believe in this semester, you do already have a web-based course and you do have a database course. You might create a database, and if that applicable, you might create a database in this course, because the project in this course, you will create a complete database, and you can use that database with your web based project. So you will send queries and retrieve and update from your website to the database using the application program feature. And that's what we are talking about. Query, I said that a lot. Query is just retrieving information from the database. Transaction. Transaction, you might guess it as well. Transaction is just sending or getting back. So whenever you send a query or an update, you will read. If it is query, you will read. If it is update, you will write on the database. So whatever you did, it's either asking for something that's a transaction, or you just want to write on the database or update the database, that's also a transaction. Protection, also database has protection techniques, such as system protection and security protection. System protection, here we are caring about software and hardware protection. With the security protection, from the name, you can get it. It's about authorization. So again, privileges. When I'm accessing the system, am I allowed to access the system? I do have an account. What I can do is what I'm doing is correct. This is security. Is there any malicious activity? Like, is there any hacker trying to intrude the system or trying to mislead the system to do something wrong? This is all security, okay? System, it's hardware and software. We just make sure to not have any bugs, to update, to keep the space enough for the database, where to save it in C or D, and etc. Maintain the database system. One of the things that it keeps maintaining the database. So how to maintain, for example, the database exceeds the limit, so you need to upgrade the hardware. You might add extra space, so to keep the data evolve without any problem. Okay, so this is one of the things that you can do with the database management system, is to evolve as requirement change over time, because every year you might have to add something new, a table new, change some requirements, and you might the database to carry on with you as long as possible. Here's one of the example that we will talk about is university. Just imagine that we have a database, it's called university. Inside the database, we have data records, which is tables. We have a students table, course table, section table, grade report, and prerequisite table. Two terms, data type and data element, okay? Data element and data type. Let me show you the this here in slide number 17 to understand. So here's the 5 tables that we were talking about: students, course, sections, grade report, and prerequisite. The data type, if I'm just getting a pen, the data type and data element. So with the data element, I'm specifying I want to have a name in the database. I want to have a student number, class, major, all of these data element, okay? And what the other one, it's data element and data type. So what I want, the data element, which is name, what type I want it to be. Here in this case, I want it to be a string or var character, we call it, I believe here. It's a string. Maybe I put 10 characters, not exceeding 10 characters. Here, the student number, I want it to be an integer, not a double. The class, I want it to be an integer. The major, I want it to be an integer. This is the data type, okay? So again, data element, it's the way I want it to be created. I want to have a name, student number, class, major. In this case, I didn't consider how many courses the student has, or when the student birth date. This is all kind of data element. Data type, it's what the type of the data. So here's that text, that a number, that's a digit, and that's 2 characters, a string of 2 characters, CS, CIS. It might be, or 5 characters, depends on our need, right? So if I just delete that and I'll come back to where we been. So here is the data type, which I already discussed, and the data element, which I already also discussed. Here's some of the types that we can see here. Just give me a second to, yeah. A string, alphabetical or alphabet characters, integer, and etc. One of the things that I already talked about, but now it's good to see it in a figure. You can see the whole white box here. If I just grab again another pen with the color blue, that box in here, as a whole, it's a database system, okay? A database system. And these are the users or programmers, users who are like me and you. For example, again, if we go to Blackboard, we are all users, okay? We are not programmers in this case, programmers who build that Blackboard system. So I will want to change on Blackboard system. Either user or programmer will enter the database system using or via application program queries. Okay, so for example, for us, I'll send a query, for example, to check my courses. For you, you will check also your courses, and you will send another query to check for the assignments, how many lectures in there. And the way you go through the Blackboard is by sending queries, and it will, when you send the query, for example, let's go through it one or step by step. So here is the user sending the query. Now the user is here, already sent the query. Now you will go to the database management system software. In here, the first thing that what the database management system, because we said it's collection of programs, one of the program is to process how the query is going to work. So after processing the query, now finishing with the process the query, now you will start with accessing the query. And in order to access the query or software to access stored data, for example, you're asking to see the lectures on Blackboard for database course, okay, or for web-based course. So already the query is processed by the database management system in here, and now another software will handle the access to the stored data. And to handle the access to stored data or to retrieve information, there is two things that will be happening. You remember we talked about the definition of the database, metadata. So first thing that it will go through the definition metadata, it will check, okay, you want the student number, you want the, in this case, in your case, you want a lecture, let's say, from the Blackboard. So it will check which lecture, do you have the privilege, do you have the course, under which constructor, what the constructor has other stuff that already uploaded there. So it will collect all the metadata. Then it will store, or it will go to the stored data and retrieve the data itself. It will return for you the lectures themselves. So first of all, it will go through the metadata, which is how the data is defined and what the information you're looking for. And then it will go through the stored data to grab whatever you are asking for specifically. And this is the way the database management system is working. Okay, construct university database. You remember the word I told you, construct. So you already define a database. So how you construct? So here we define. Here we define the data type and data element. Now we want to construct the database. So we will start store information. I will start fill the tables. See here, the tables were empty in defining. After constructing, now the tables have some information. So for example, we have 2 students, we have 4 courses, we have about 6 sections, grade reports and prerequisite. Okay, so that construct university database, store data to represent each student, course, section, grade, report, and prerequisite. Relationships among the records. You can see some relationships. It's not obvious for you now, but we will cover that inshallah in the coming lectures. For example, here we can see that the course, every course or every section has a course. So for example, this section 85 has a course number, and that course number coming from here. Another section has a course number coming from here, and etc. So every section has a course number. And that's kind of relationships in here. Also, we can see that grade report, every grade has a student number and section identifier. The student number coming from, okay, and grab the pencil again, or the pen. The student number coming from, oh, sorry, coming from up there. The student number, excuse my writing, I'm using the mouse. And the section identifier coming from here. So that's also another relationship between this table and these 2 tables, the student and section. So we can see some relationships between the tables, which will be, inshallah, clear in the coming lecture. What else? We have manipulation involves querying and updating. So we talked, again, I like to come to remind you of the process. Okay, defining, then constructing, then manipulating, then sharing, right? So here we are following the same process. We already define, and then we construct, and now we're talking about manipulation. So sending queries or updates to the database. Some examples of query: retrieve the transcript. For example, if I want to retrieve a transcript for a student, let's say 17, which is, or his name is Smith. So I'll go through the grade report and I'll take this information. So for example, let me just give you one example here. The student Smith, his student number is 17. So the student has 2 courses with the grade report, and these are 2 sections, and here's his grade. So to know the course name, I'll go to the section here, and I see 112, which is this one, and 119, which is this one. So a student has these 2 courses, which I can get their name from here. So this is the first course, and here's the second, right? So the student got B in 112, which is discrete mathematics, and the students got C in 119, which is the intro to computer science. And based on that, I can create, or I can do query. So now I'm query, or I'm doing a transcript for this student Smith, and that is query. Okay, what else do we have? List of the names, or list the names of students who took this section of the database course offered in fall 2008 and their grades in the section again. So the list of names of students who took this section, you will see, if I just remove, if you go to the section, you will try to see who took the database course. First of all, we have to know the database course number. So the database course number is CS3380, which is this one here, and this section 135. Let's go to here. Who took 135? Only one student, who the student number is 8, which is Brown. So Brown was the only student here who took C++ in fall 2008. This is 2008. And he got a, okay, this is also query. So I'm just asking, I'm not changing anything. List of the prerequisite of database course. Here we can see the prerequisite of the database course. Here's where's the course number? The course number, we say it's 338. Okay, these are 2 database course number. And here's the prerequisite you need in order to take database. Okay. Erase. Okay, let's go back. Erase. What about update? With update, just change the department of the data structure to CIS. You can, for example, update data structure here. Data structure, database. Data structure to CIS. So this is, it's CS. I'll just change it to CIS. Okay. Create a new section of the database course for this semester. You will just create a new section here. It's called database, okay, with the same number. You will give it a section identifier because this is unique, I believe so. And that will be fall maybe, and this will be 2022. And the instructor, Hussein. This is also one of the updates that you can do. It's adding intergrade of A for Smith in the database section for the last semester. You can, with the previous example, you notice that only we have Brown got A. Now we want to add also Smith to here, so we will add extra record to the table. Okay. What else? We have the phases for design a database. So there's 4 phases to design a database. First of all, you collect the requirement. For example, if you have a customer, now the customer wants to create a database. You will sit with the customer, you will ask him some questions. Based on those questions, you will create the database with him. That might be done with a piece of paper, with the with maybe a PowerPoint slides, with the drag and drop. easy tool like what you will learn in HCI, Human Computer Interaction, in this semester. And that's quite easy. And then you will have the conceptual design. The conceptual design, like after you're collecting already the requirement from him, you want to show him the concept that or how the database is going to look like, and how they communicate, or like how the relationship between them it's going to be looking like. Still, you are not putting these inside the software or inside the database management system. You're just discussing with him the final product and how it's going to be look like after you're collecting and understanding all his requirement. And thirdly, you will start with the logical design, which inshallah we will cover in the lab. So there is something that called model. We will create a model, but still we didn't publish the data. We haven't yet published the data to the system or to the database management system. We're just creating the model, and we can still update and change without any problems because it's not published. Okay. And lastly, we will do the physical design. In this case, we will having the database published in the server, working properly, with the information already added to it, like the name of the student already there, the class is already there. And in this case, we can update and sending queries based on the needs. You can change with the database, but it won't be flexible as when you start with the requirement specification and analysis. Now it's more harder to change the database because it's already built and you have already the relationship and constraints already there, but it can be done based on the customer need. Okay, so characteristic of the database approach. We have two characteristics mentioned there. One is old and the new one. The old one was called traditional file processing. It's based on the program. So I'll give you an example. Let's say I'm responsible to collecting fees from students, and this is an example I got from the book. Okay, so let's say I'm responsible to collecting fees of university from students. So what I will need, I want the first name, last name, the ID of the student. I might need the birth of date, his credit card information, and the amount of money he paid and the amount of money he will pay in the future. Those are the information that I will be collecting from the students if I want to have the fees. And I'm still using the traditional file processing, so that the guy will be having his own database, or will having its own file, let's name it, with this information. Another one is responsible for creating the student transcript. Okay, so in order to collect the student transcript, I will need the student first name, last name, ID, his birth date, the courses he's got, and the grades for every course he registered in. See, and that guy who creating transcript will have another complete different file with this information. So just imagine now I'm having two people. One cares about the fees, okay, and the money, and the other cares about the transcript and printing them. And you can tell both of them having the same students. So both of them saving the student's name, both of them saving the student's last name, the IDs, the birth of date, maybe the addresses, but only has each one of them has its own differences. So the first one will have maybe 3 to 4 columns about the money, and the other one has 3 to 4 columns about the grades. And we can see how it's redundant. So, and how it's going to waste spaces. Okay, so that's the old way to the traditional file processing. It's to have for every job, or for every topic, or for every aspect its own file. But with the database approach, no, we will have all the information about all the students, and based on the user need, the user, I mean those who are working, even collecting the fees or want to create a transcript, based on their needs, they will generate reports, or they will do some queries, and they will get whatever they want without creating 2 different files, having the same student but with different characteristics. This is the whole scenario. So with the traditional, you have a lot of waste of time, wasting of space, wasting of management. But with database approach, no, you will have everything in one repository. to maintain data that is defined once, then accessed by various users. Main characteristic of database approach, we have four main approaches, or main characteristics of the database approach. The first one is self-describing nature of database system, as installation between programs and data, and data abstraction, support of multiple views of the data, sharing of data, and multi-user transacting processing. All of these characteristics, we already discussed them before. Okay, so these are characteristics of the database, and we discussed them before, but we will discuss them in different angles. We will talk about them now one by one to understand them more. The first one, it was self-describing nature of database system. So database system contains complete definition of structure and constraints, and we talked about that before. So it's already have, or the database management system, not the database alone, the database management system, DBMS, it will have the metadata, if you remember, which will describe, put the constraint, how many characters, how many digits, and that's very useful. Okay, so metadata describe the structure of the database. Database catalog, which we already talked about it before, it's regarding the metadata. So in the database catalog, why we use database catalog? Again, database catalog, what's inside the database catalog? The metadata. Okay, so why it's used? It's used by the database management system software, and also database users who need information about database structure. So those users who wants to know how the database is built, we will go to the metadata or the catalog, the metadata under the catalog. So we're gonna find all the information, constraints, and the information we want. Okay. So program data independence and program operation independence. Here we are talking about the second characteristic of database. It's called isolation between programs and data. One of the great things that we have also to mention. Here we have an isolation or independence, استقلالية, between program and data. Let's read the definition. Structure of data files is stored in database management system catalog separately from access programs, which means any changes of the structure of a file or a database will not require changing all programs that access that file. I'll give you an example. Okay, so let's say that in the data, so I'm talking about, again, program and data independence. So let's say now I have a program, whatever that program I designed, that program enter the database, sending query, collecting information, and getting back. Okay, let's assume that program entering the database about the student, which I told you about before. It has the first name, last name, and the student ID, date of birth, and how many courses it has. Okay, so now the program also, or the program always goes to the database, collecting the first name, let's say, and the last name, and getting back, or closing the program. Okay, if I change the data, so let's assume I change the first name from, it was 10 characters, now I change it to be 20 characters. Okay, that shouldn't affect the program at all. Is that clear? So whenever the program comes again and asking for the first name, it won't be bothered to know how many characters the first name it was and how many characters now it is. It will just ask for the first name and it will get back. That's the whole story. So whenever you change something in the database, the program wouldn't be affected. And that was something of the cons of the traditional file processing. With the traditional file processing, if you change the data, you need to change the program. Okay, but with the program data independence, that in database management system, if you change the data, you don't need to change the program. Okay, so whenever you change the data, the constraints, now let's assume that you want to change the constraint from of the number of courses. Every student must be not from 3 to 5. We want them to have courses from 4 to 7. If I change that in my data, the program wouldn't be affected, because whenever the program comes and asks for how many courses the student has, the database will provide, and the program will just take and get out. And that's totally the story. Another isolation between the program and data that database provide, it's called program operation independence. So we have a program and operation, الاستقلالية ما بين الأوامر والبرنامج. To understand it, or to get the idea, operations means here what? We are referring to functions and methods. You already created functions and method in Java. You already created function and methods in C++. I believe if you already took Python, I'm not sure if you took Python in prepared year, but if you already know functions and methods, it's the same, operations. What it consists of? It consists of interface. Here, the interface, right? What interface? The interface is the name of the method. Whenever you want to create a method or a function or operation, in this case, you need to give it a name, right? So you will give it a name. So that's considered to be interface, and you will give it the argument that you will pass. For example, if you are creating a function that just could sum two numbers together, so you will provide two arguments. It might be doubles or it might be integers based on your need. So you will also specify the arguments. So we call this as a whole is interface. And inside the function, what we have the body of the function where we do the implementation. So we would just add them together, two numbers, and then return the answer, right? So that's called implementation. So whatever inside the function is called implementation. What here it says just whenever you just change the implementation, which is the body, it won't do any trouble with the program. So whenever a program, for example, called the sum method, and you just change the implementation, which is the body inside, to do whatever else that you wanted to do, the program wouldn't sense it. البروجرام المفروض ما يشعر بأي مشكلة. ليش؟ لأنه أنت ما غيرت الانترفيس. You didn't change the interface. You just change the implementation inside. So the program will just go ask for that function, which is called, for example, sum two numbers, and provides two argument. And now you already changed the implementation or the block inside, so the program will not sense it. It will just work smoothly. And that's called program operation dependence. And that's also one of the features that is provided by database management system. Data abstraction, it's under the isolation as well of the data and programs. Abstraction, it just provides us these features of the independency between the program and data in here, and the program and operation. All of these are available for us because we have the data abstraction properties in property in database management system. So it's the father or the top section. We do have what we call conceptual representation of the data. And what we mean by conceptual representation of the data actually is stored in a way inside your system. It might be stored in C or D. It might take for integer 4 bytes, for double 8 bytes, or whatever. For a string, it depends about how many characters do you have. You as a user, you don't care about how it's going to be saved. You just want to see the data whenever you call them. If you want to call the Smith grade, you want to see the Smith grade. If you want to get the Smith courses, you want to get the Smith courses, it will be retrieved to you. You don't want to know all these information. And what we call this thing is conceptual representation. You just do not include all the data, or do not include details of how data is stored or how operations are implemented. You just show the user what he wants to see, because the user doesn't care. Like, for example, here I just showed the user these tables. And these are conceptual representation. These are examples of conceptual representation. I don't show you how Smith is saved in the database, or where is saved, and in which C or D drive is saved. So that is considered to be conceptual representation. Data model, type of data abstraction used to provide conceptual representation. It's a type of data abstraction, okay, and also to provide conceptual representation for us. Here is metadata. We were talking about metadata a couple of times. So here's a figure showing us the metadata of figure 1.2, which is this one here. This is 1.2. Here's the metadata of figure 1.2. We can see the relations. So we do have how many columns? We do have 5 columns and 5 tables. For example, student table has 4 columns, course has 4, section 5, and etc. And we can see another table that shows us all the columns. For example, here name from the student table, and the data type is character 30. Again, character 4, it's the student number. Class is an integer from a student, and etc. One thing that I just want to mention again, so the data type, it's what we were talking about here. If you remember, where is it? We're talking about data type and data element. Yeah, here in slide 11, data type and data element. So data type, it's specified in there. You can see character, integer, and etc. And data element, you can see it here. So I want to have name, student number, class, major. All of these are considered to be data element, and all these here are considered to be data type. Okay. Here, for example, course number, you can see this column here, course number. Then the data type of it, it's X, 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 N, N, N. So I'm putting like a default way to have it. I want to have 4 alpha characters followed by 4 digits. So I want, for example, to have it CISS, then 3, 3, 4, 5, etc. And this is the way I want it to be implemented. What else do we have? We also, if you remember, talked about support viewing. And this is one of the characteristics of the database. Just let me delete this. Where's the characteristic? Support of multiple views and or views of the data. So this is the third characteristic, subset of the database. So in case, for example, you are wondering or you want to know information about Smith, and you do have all the students in your database, so you just want all information about Smith, you can do subset of database. So you will ask for Smith, and you will do like some command that will return for you also or all the information about Smith. Contains visual or virtual data derived from the database files, but not expressly stored. And that's the idea. So you don't need to have different databases like with the old way, with the file, what was called traditional file processing. You don't need that. So with the view now, it summarizes for you everything. If you are concerning about fees, you can return all the students' information with the fees or transcript, depends on the need. Multi-user database management system. User have variety of distinct applications, must provide facilities for defining multiple views that also provided by the database management system. Sharing. I told about sharing and how it was one of the most powerful characteristics, or how it is one of the most powerful characteristics in database management system. Allow multiple users to access the database at the same time. And we have something called concurrency control software. Let's assume that you are reserving a hotel and another guy from anywhere around the world is reserving the same hotel that you are reserving. Is there going to be any conflict? Like, is it going to be both of you reserving the same room and then that will be an issue for both of you? No. In database, we have something called concurrency control software, which ensures several users trying to update the same data do so in a controlled manner. Results of the updates is correct. So it will, has its own way, which we'll inshallah also cover in the coming slides or coming lectures, and how concurrency control software working and how manage to address these conflicts. Also, we have online transaction application. It's actually concurrency control software, but in online database. And that is just the difference between them. Transaction, we mentioned previously transaction, but here just we want to say it's important. So it's central to many database applications. All database, or most database application depends on the transaction to update and query from the database. And also we want to mention that executing program or process that include one or more database, you can, for example, let's assume when you are reserving a hotel, so you are going to send maybe multiple queries without you knowing to different database. One query it will be sent to the hotel, and the other one it will be sent to the bank, and the other one it will be sent to the whoever providing the service for you, booking or whatever the website is. So you are sending to 3 different places, and the way it's organized, it must be isolated. As a whole, that one transaction that contains 3 commands, one for the bank to get the money from your bank and put it to the who provide the service for you, and the other it might be booking.com, and the other it's the hotel itself. So you're now sending a transaction to 3 different databases, and it consists of one transaction. The thing is, the transaction must be isolated, or we have to provide the isolation property, which is provided by the database management system. Because of that, it's one of the characteristics. So each transaction appears to execute in isolation from the other transaction. So your transaction, when you did the reservation, it's right, you are dealing with the 3 databases in this example, the booking, the bank, and the hotel. But it's this transaction by itself, it's isolated from another guy from anywhere around the world is doing the same or reserving from the same hotel. So your transaction that consisting of 3 or changing 3 databases, it will be completely isolated. Atomicity, and that's one of the powerful thing that is also provided by database management system. It's in our example, we are changing 3 databases. Let's assume that you took, like, for example, the money is taken from your account from that command, but it wasn't transferred to the hotel or to the booking.com. In this case, the transaction has some leakage. The transaction is not fully executed and completed. So with database management system, atomicity property is there to just make sure and guarantee it's either to operate all the data or all the commands in the transaction, or delete all of it. So whenever a problem is happening in the way, it will be cancel all the transaction, which consists of 3 or consisting of changing 3 databases. Is that clear? So it's either all of the commands in that transaction, or neither or none at all. Now we want to talk about the actors on the scene, people who is interacting with the database directly. We have the database administrator. It's the admin of the database. He is responsible to provide authorization access to database, giving the privilege. You are the student, you cannot access or you cannot add courses. People who can, other people can add courses for you. You are an instructor, you can have these courses and you can add materials to these courses. That all be done by the data administrator or DBA. So he is providing the authorizing access. He creating for you a username to enter the database, for example, coordinating and monitoring its use. So he just watch what's going on in the database, and he getting the responsibility of any errors that's happening in there. Acquiring software and hardware resources. Whenever we need to expand the database space, we will ask the database administrator to expand the database for us, and that is his responsibility. Database designers are responsible for identifying the database or the data to be stored, choosing appropriate structure to represent the this data. They are defining the database, so they just suggesting how many columns, how many tables, how many relationship do we have, how many of this we will add, and etc. So they will put the appropriate structure, and they will put the constraint on the database, identifying the data to be stored. End users, who are us, people who will use the database after all. For example, if you have Amazon, they have their own database, which is already, they have the database administrator and the database design, and we will be the end users who will use the database in order to collect, for example, some items, buy some items, sell some items, watching or browsing the items in the store. System analyst, people who determine the requirement of end users. So those people will regularly checking okay, end users need to have this feature. We have to add it to the database. The end users might prefer to have a basket that saves their information even if they didn't buy. End users might prefer to have a star buttons in case they want to get back to it. So these people who just collect requirements, and people who will implement those requirements called application programmers. System analysts just collecting requirement, and application programmers will implement those requirements or specification as programmers. And those programmers, again, who will be accessing the database, if you remember here in this figure, to change on it or to apply the changes. Okay, what else? Workers behind the scene, those are those who did something regarding the database, but we are not dealing with them, or they are not dealing with our database regularly. For example, database management system designers and implementation. Design and implemented the database modules and interfaces a software package. Those people, for example, here, who just created for us the database management system itself as a system. They provided the packages, they update the system for us in order for us to just use it as administrator, as end users, as programmers, as analysts, etc. So we just, for example, buy Oracle or something, and we will use it as a database. So Oracle, it's a company that provides for us the database, and they will just sell it for us to use it. Those are behind the scene. Tool developers, people who are developing tool for the database, and we use after that these tools to enhance or to develop our tool. For example, we have a tool, it's called MySQL, which we will use in the lab as well. This is a tool that is already provided to us, and those people considered to be behind the scene. Operators and maintenance personnel. Those are people who are like, let's assume that you are in the company, and the company has a database or a server like storing the database. So there is a people who is responsible for maintenance. They keeping eye on the, for example, the computers, the fan, the doors, the other stuff. So hardware, software environment. These are also people behind the scene, not contract or like contacting with the database بشكل مباشر. Okay, advantages of using the database management approaches, which is the last thing that we want to cover in this lecture. Controlling redundancy. We don't want to have redundant data, as we just mentioned that with the file transaction processing. We don't want to have different tables that has different information. It has most likely the same information, but with just different columns in between. So what that is called data normalization. So rather than having two database or two files, one for collecting fees from students and the other collecting certificate from students, now we put them in all one database. That's called data normalization. So we will have all the information there, and then we will collect whatever we want to have from this database by doing viewing or querying. Okay. Denormalization is the opposite. So you just do redundant thing. For example, you can, here's an example I can give. Where's the mouse? Okay. See the student number here. It's enough for me, right? It's enough to have the student number so I can know who is the student. But maybe some people will add also the student name in here, and will also add with the section. It's known to me that 112 is that. No need to do redundant stuff, but some people might as well add in here course number. Okay, and he might add a student number. So by adding these, you just put redundant stuff you don't need to the database or to the tables that you have, and that's called denormalization. Okay, so we have normalization and denormalization. Sometimes necessary to use controlled redundancy to improve the performance of queries. Restricting unauthorized access. Again, you do have privileges. I talked about that a lot. That can be done by the system administrator, who will just provide the privileges or صلاحيات للأشخاص المناسبين. Security and authorized subsystems. So you do have username and password, strict username and password, changed regularly, and etc. provide storage structures and search techniques for efficient query processing. All of these are advantages of using database management system approach, okay? So by having a database, you will have a place where you store your data persistent forever and there, and it will be there, and you can do searching and queries and etc. Also, you can have a backup and recovery system. So whenever a disaster happens, you already have the backup. You can specify when you want to have the backup. For example, you can have the backup daily, whenever like the work is finished after 4 p.m. The system will do the backup, or monthly or weekly or yearly based on your need. And then whenever like a natural disaster happens, you lost of the data, an attack happened to your, maybe a cyber attack happens to the company, you can do the backup without any problem. Providing multiple user interface. So with the database management system, you have different type of user interface. You have graphical user interface, you have command line interface, different type of interfaces that can be provided for users. Representing complex relationship among data, you can have with the database management system as an advantage, complex relationship, which we'll talk inshallah about it in the coming slides or coming lectures. Enforcing integrity constraints, you can put constraints. One of the or two constraints are mentioned here. The referential integrity constraint. For example, you can say every section record must be related to a course record. Here is the section. Let's go back to the table. Every section record, where is it? Sorry. Every section record, get the pen. Okay, here's the section record, must have a course number, isn't it? That's what it was saying, right? Every section record must be related to a course record. And that's one of the constraints that can be added to your database. It's called referential integrity constraints. Also, we have the key uniqueness constraints. Uniqueness is important, especially if you want to have it in databases to reach to the people. Now we do have all university cards, right? And you have universities IDs. Every ID that you have, or all the IDs that we have in university are unique. So the number you have as an ID, it's unique from all students in Imam Abdurrahman bin Faisal University. Why? Because in database, when we want to reach you, it's easy for us to reach you. We just want to put your ID and all information about you will be there. If there's no uniqueness, it's hard to reach people in case you want them or you want to collect information about them. So every course record must have a unique value for course number. We also have what we call rules, permitting inferencing and action using rules, two types of rules, trigger and stored procedures. With the trigger rules, whenever you update the tables, whenever you do any updating to the table, there will be a rule activated. What a rule activated means, like whenever you update one of the table, there might be a message that appeared, the table is updated correctly, or will be happening, some operation will work after you update the table. So this is the trigger. It will be triggered whenever you update the table. Something will be happening. That's one of the rules you can apply to the database management system. And also you can apply another type of rules called stored procedures. It's more involved procedures, it's more complex, and its purpose to enforce rules. Like when a condition is met and you want to enforce some rules to be happening, you will use the stored procedures rules. So what you just want to know now, it's more complex and it will enforce rules. And with triggers, it just update, whenever you update the table, it will just trigger a rule and our rule will be activated. This is a summary: database, a collection of related data, records of facts, database management system, generalized software package for implementing and maintaining a computerized database, several categories of database users we have. This is all. See you inshallah in the lab, and hope you all the best. Keep watching all the lecture. Do not miss any of them. Try to be up to date and catch all the information. Whenever you want to know more about a specific point, you can go to the book. Everything is mentioned in the very clearly, and all the information from these slides are mentioned in the book as well. All the best, and see you soon.